Today we are going to discuss about projectile motion. What is projectile? Let us consider a javelin throw. A javelin follows a curved path and lands on the surface of the earth. Such objects like javelin which moves along the path determined by gravity and air resistance are called projectiles. The path followed by projectile is called trajectory. An object dropped from a height, an object thrown vertically upwards, an object thrown obliquely upwards are examples of projectiles. In all these cases, for influence of air resistance is neglected. Types of projectile motion. There are 6 types of projectile motion, but in your textbook, 2 projectile motion is given. One is horizontal projection, the other one is angular projection, otherwise called oblique projection. Now we will see about angular projection. Let us consider a body be projected from a point O with initial velocity u, making an angle theta with the horizontal axis. The velocity of the projectile at any point on the trajectory goes on changing both in magnitude and direction. The velocity is resolved into 2 components. One is ux is equal to u cos theta, the horizontal component. Second one is uy, that is equal to u sin theta, the vertical component. There is no acceleration in the horizontal direction, that is a equal to 0. And in vertical component, the acceleration ay is equal to minus g. The vertical component of velocity changes with time, and at the highest point the uy becomes 0. But in horizontal component, all the particles, the horizontal component is constant. From this, it is clear that uy decreases when time increases and becomes 0 at p. At this point, the velocity is only along the horizontal direction. With further increase in time, the vertical component of velocity gradually increases in the downward direction till the particle strikes the ground. So now we will see the summary of this projectile and angular projection. So in x direction, ux will be equal to u cos theta, ax, that is acceleration, will be equal to 0, and net force will be equal to 0. In y direction, O to p, the velocity will be goes on decreasing, and at maximum point the velocity will be equal to 0, and from p to q, once again the velocity will be increasing. And in y direction, the acceleration will be minus g. Now, in this point O, there are 2 components. One is horizontal component, that is u cos theta. The other one is vertical component, u sin theta. So, at particular point A, here the horizontal component, there is a change in the velocity. Here it is ux, here it will be vy, because already I told there will be decrease in the velocity. So here vx will be equal to u cos theta, vy equal to u sin theta. In this case, all the horizontal velocity is constant. Now we are going to find out the resultant velocity of the particle at any instant t. Now I want to find out the resultant velocity of this particular point. So v vector is equal to vx I cap plus vy j cap. Vx I cap and vy j cap. So find out the magnitude for this will be equal to square root of vx square plus vy square. So here vx is nothing but u cos theta. Vx is equal to u cos theta and vy equal to, we know that equations of motion v equal to u plus at. From this I can find out the value for Vy. Here Vy and this is Ay. So Vy is equal to here initial velocity. So what is the initial velocity? U sin theta. U sin theta, and the acceleration is minus g. So it becomes minus gt. So this is Vx value and this one is Vy value. Now you substitute this Vx value and Vy value in this equation. So V is equal to square root of Vx value is u cos theta the whole square plus, and Vy value is u sin theta minus gt the whole square. Clear? Now you square this one, u cos theta square, u square cos square theta plus this, it is in the form of a minus b whole square formula. So a square minus 2ab plus b square. So it becomes u square sin square theta minus 2u sin theta gt plus g square t square. This u square cos square theta and u square sin square theta. So in this u square is common, and in bracket you will get cos square theta plus sin square theta. So cos square theta plus sin square theta is nothing but 1. So I can write as u square minus 2u sin theta gt plus g square t square. This will give the resultant velocity. Now we are going for direction tan alpha. Here the angle will be alpha. So tan alpha is equal to opposite by adjacent, that is Vy by Vx, that is equal to, so Vy value u sin theta minus gt divided by Vx value is u cos theta. So I need only alpha. So alpha is equal to tan inverse of u sin theta minus gt divided by u cos theta. Next, we will see maximum height reached by the projectile, and it has been represented by x max. So I want to find out this particular object which is at maximum height. So we know from kinematic equations of motion, v square is equal to u square plus 2as. Since the object moves in vertical component, I will be writing it as this one is Vy, Uy and Ay. So here Vy is nothing but final velocity and Vy is equal to 0. So 0 is equal to initial velocity u sin theta the whole square, and acceleration is minus g. So I will write it as minus 2g, and s is nothing but the height. I will be writing it as x max. So 0 is equal to square this one u square sin square theta minus 2g x max. So it becomes, if this u square sin square theta, it becomes to this side, it becomes minus u square sin square theta is equal to minus 2g x max. So minus and minus cancel, I need x max. So x max is equal to u square sin square theta divided by 2g. Next, we are going for time of flight. Now the object from here, if it moves towards up to P, is what we can call it as time of ascent. From P to Q, the flight, what we can call it as time of descent. If I add this time of ascent plus time of descent, it will give time of flight. Here the component is Uy is equal to u sin theta. So now we will calculate time of ascent. V is equal to u plus kg. From this equation we can calculate the time of flight. So if the object moves in y component, so I will be writing it as ay, uy, and this one is ay. From here, the object moves to in this region. So that is from this region, that is from O to P, and this will be the final velocity, and Vy is equal to 0. 0 is equal to initial velocity is u sin theta minus ay is g into time of flight. That is here the time of ascent. So minus u sin theta is equal to minus g into ta. Minus and minus cancel. So time of ascent is equal to u sin theta divided by g. Now we will calculate for time of descent. So time of descent is equal to, we know that g is equal to u plus at, ay and ay. So from P to Q, and this will be the initial velocity, and here this Q will be the final velocity. So Vy, it is minus u sin theta is equal to, and initial velocity is 0, and the acceleration is minus g into time of descent. So minus u sin theta is equal to minus g into Td. This minus and minus will be cancelled. So time of descent is equal to u sin theta divided by g. Now if I add these two values, I will be getting time of flight. So Tf is equal to time of ascent plus time of descent. That is u sin theta by g plus u sin theta by g. So totally you will get 2u sin theta by g. This will give the time of flight. So next, horizontal range, and it has been represented by r. That is the distance between the point of projection and hitting point, what we can call it as horizontal range. Here the horizontal range, it moves in x component. So here acceleration is equal to 0 and initial velocity is equal to u cos theta, and from the equations of motion, s is equal to ut plus of at square. From this we can able to calculate the range. S is nothing but the distance, I will write it as r, and this one u is initial velocity, it is ux, this t is called time of flight, a acceleration, and this t is nothing but time of flight. Say ux is nothing but u cos theta, and this time of flight 2u sin theta by g. So 2u sin theta by g, and here acceleration is 0, so no need to put this value. So r is equal to 2u square cos theta sin theta divided by g. So r is equal to 2 cos theta sin theta is nothing but sin 2 theta, this u square divided by g. So 2 cos theta sin theta is nothing but sin 2 theta. And the last one is equation of trajectory. So what is trajectory? The path described by the projectile. The path described by the projectile is called trajectory. Now I want to find out the path. From O to A, how much distance it has been covered, the path. Just to take this point, and in coordinate, that is in x coordinates, the distance is x, and in y coordinates, the distance is y. Now I want to find out the path. So s is equal to ut plus of at square. Now I am going for this horizontal one. This is x, ux of ax here, and this s of x is nothing but the distance from O to here, and let it be x. ux is nothing but u cos theta into t, acceleration minus b, so it becomes, and in horizontal component it is 0, so this overall it becomes 0. So x is equal to u cos theta into t, therefore t is equal to x divided by u cos theta. Next we will go for the vertical component. X is equal to ut plus of at square, and this becomes y. So x y is nothing but y, and uy, that is vertical direction, that is u sin theta, and p value it is x divided by u cos theta, x divided by u cos theta, and the acceleration it is minus g, so it becomes minus of g, and t is x by u cos theta, and since it is square, I will be squaring it x square, this one is u square cos square theta, and u will be cancelled. Sin theta divided by cos theta is nothing but tan theta. I can write x or tan theta into x minus of g, x square, that is of g, x square by u square cos square theta. In this equation, tan theta is constant, x is variable, of g u square cos square theta is constant, and x square is variable. So I can write this constant tan theta will be a, and this one is x, and minus sign. This constant I write it as b, and x square. This equation in mathematics, it gives the equation of parabola. From this, we can conclude that this projectile under an angular projection is parabolic.